Okay, my friends, so for our first statistical example, I wanted to look actually at an article that was brought to my attention last time I taught this class in person. As you probably no doubt have noticed, I write in all caps. And part of that is a reaction to my own Catholic school upbringing. I was forced to learn cursive, and I'm going to talk more about that when we go to the board to draw some pictures to accompany this research article. But a student kept me after class one day and said, you know, cursive is way better for brain development than printing or typing. And I said, oh, that's interesting. What do you mean? And how do you know that? And, you know, we brought some studies up together. We got on our phones and started Googling. And this is one of the ones we found. This is one of the most recent ones. Here's the news article from sciencenews.org that breaks it down. Handwriting may boost brain connections. Okay, boost brain connections. That sounds promising. The finding adds to growing evidence of handwriting's benefits. Okay, but let's be better than normal Americans and read past the headline. Okay, writing out the same word again and again in cursive may bring back bad memories for some. Sure does, man. Sister Grace, Catholic school. Ugh. Plenty of previous research has shown that handwriting improves spelling accuracy, memory recall, conceptual understanding. Okay, this is good stuff. In the new study, psychologists Audrey Vandermeer and Ruud van der Wiel, okay, so they're from Norway, and they recruited, okay, we got some students we're recruiting, and that's kind of freaky looking, but I guess that's how they're measuring brain interaction in cursive versus typing skills. Okay, cool. That just gives me something to think about, to talk about later. I went and found the study that they published. Here it is right here. Handwriting, but not typewriting, leads to widespread brain connectivity. And then there's a lot of psychology talk in this paper, a lot of it. But the big thing that I want to chat about is way down here in their results. I'm going to find it way down here. We're going to go to the board here in a second, and we're going to chat about what these results mean. And there is definitely a lot of stuff going on with this study that's beyond the scope of Stats 243, but we can break down this conclusion right here. Okay, so they say positive connectivity is significantly more prominent, and then they give you a little p down here that's less than 0.05. That is what I want to focus on next. Let's go to the board and chat about this. Okay, my friends. Now, the researchers have a theory that handwriting, cursive in particular, and I'm going to take one quick sidetrack here and give my rant about cursive handwriting. Cursive only exists because when we first started writing with portable writing instruments, they were quill pens that needed to be refilled with ink. So the only reason cursive exists is so that we didn't pick the pens up and put them down and dry out the quill. So cursive has outlived its usefulness. Rant over. Now we're going to talk about whether or not cursive somehow stimulates the brain and creates better learning environs than typing does. Okay. The researchers have shown, according to their study, that handwriting and typing create different learning experiences. Different. I'm not going to say better. I'm going to say different. In order to show that, though, they need to be able to demonstrate a statistical difference between them. So they don't actually start by assuming they're different. They start by assuming they're the same. So the null hypothesis, which is the status quo, is that there is no difference. No difference between, you know what? I'm going to write this a better way. I'm going to write cursive brain development. This is going to be better. Cursive brain development is the same as typing brain development. Cursive typing, exactly the same. So you've got two ways of getting ideas down, and there's no difference in the brain development involved in those two ways. Okay. What the researchers want us to believe, and what they think their research has shown, is the alternative to that. Now, what's the opposite of cursive and typing are equal? That cursive and typing are not equal. So that's going to be the alternative hypothesis. The alternative hypothesis is that cursive brain development, pretend that's the word development, is not equal to typing brain. I want to try to write this last bit in cursive. That's bringing back too many bad memories. Development. Okay. They are opposites. They can't both be true at the same time. One has to be true, one has to be false. Now the problem is, we're never going to know which one is true and which one is false. Statistics is based in probability. That's what that little P stood for down there. We're going to get back to that in a second. What the researchers are trying to suss out, though, is which one of these is easier to believe. Now, here's where the research methods come in. And this is where this report gets a little bit outside. Actually, most of the reports we're going to look at in these next 2 days, the procedures themselves are very, very specialized, getting into the worlds of exercise, physiology, psychology, things like that. We're going to focus on their results and what the results mean. So we're going to trust in all of these studies that we look at that the methodologies were done correctly. Now, in this particular case, the researchers started by assuming that the cursive and the typing brain development is the same. What I'm going to do is, I want to leave those up there. Let me, give me a second here. Let me adjust the camera. I want to add another graphic to go along with this, and I'm out of board here, and I think we need a larger board. Give me 1 second. The Norwegians were studying whether or not there is a measurable difference between typing and cursive. We looked at this kind of last week with t-testing, and I wouldn't be surprised to find if they used some kind of a t-test or a variation of a t-test in this, because they're looking at the difference between cursive and typing, most probably within one student. I'll dig more deeply into that and see if I can get the data for us to test later. But what they're looking at is really the differences in the brain development. Development. If there's no difference, then that difference would be zero. Like we looked at last week. Remember, we were trying to see if there was a difference between thumbs and forefingers and dominant and non-dominant hands, and we were comparing that to the idea of a zero difference. Now, it doesn't have to be exactly zero. It just has to be close enough to zero within an acceptable range of variation. Now, what does that mean? Well, that is what we've been looking at all term with confidence intervals. That is a acceptable realm of variation to capture a parametric value. So somewhere out there in the population is the true difference in brain development between cursive and typing. Our job is to see if we can see what that difference is. The assumption is that they're the same. You have to assume they're the same. You can't assume that they're different before you know that they're different. You assume that they're the same. So here's what we're going to do. We're going to assume that zero is the actual difference, but we're going to build a distribution around that difference. And that difference distribution, otherwise known as the null sampling distribution, is going to be bell curved most likely in a situation like this because of the central limit theorem again. Here's the average, the highest point on the curve. If you get data that lands over here, so if it's a little bit positive, let's suppose you do the study and it comes back a little bit positive, are you concerned? Statistically, no, because you're still pretty close to that average of zero. What if you're here, just about there? Probably not either, because you're still statistically close to that average of 0. When do you start getting concerned that you're too far away? Well, this is where confidence intervals come in. So what statisticians do around the null hypothesis is they set up a 95% confidence interval around the null hypothesis. And they say, okay, that's the distribution that corresponds to the null hypothesis. I'm now going to do my study, and I'm going to get results from that study, and I'm going to drop those results onto this curve. Depending on where they land, I will then know which of my hypotheses to believe. So if we do this study on differences in brain development, and we normalize our data so that it has an average of 0, just like this one, using the methods we've already studied in this course. If we land anywhere between this LCL and this UCL, that tells us we need to believe the null hypothesis. Statistically, it's called failing to reject the null hypothesis. That's the old classical language. I like to say, well, there's no reason not to believe it because you landed close enough to the average. Again, close enough has to be measured statistically. And generally speaking, 95% confidence is that number. More on that in the next video. But let's suppose you land out here, or out here, or out here, or out here, or way the hell over there. That curve keeps going. Well, now you've landed far enough away from that 0 statistically that you no longer believe that there's no difference. You believe that there is a difference, which means if you land outside of that interval, you're going to believe the research or alternative hypothesis. This is all based on the tests themselves. We're going to start doing tests next week for the last 2 weeks of the course, I guess. Right now, I'm just trying to drive home the point of what these little symbols mean that you see in these reports. Now, to recap, you start any study with a set of hypotheses, a null and a research or an alternative. Any study starts that way. You then build the test around a sampling distribution that represents this. So in other words, you assume that until data shows you otherwise. It's kind of like court, innocent until proven guilty. That makes sense. Innocent being status quo. There's no reason to think cursive's any different than typing, unless we see data that significantly differs from that belief, which is what it sounds like these Norwegian folks did. Okay, in the next video, I want to break down some of these terms a little bit more.